Trig, arcs and sectors. So first of all, we have to look at what is an arc and what is a sector. And arcs and sectors always refer to circles. So if we look at this diagram here, we can see that the arc is basically a portion of the circumference of a circle. So in other words, if I was to start here, so if I put a little dot on my circle, on the circumference, and I was to travel a certain distance along the circumference, then what I would have traced out is an arc. So it's basically a fraction of the circumference. Whereas if we look at the sector then, the sector is the area that is bounded between the two radii and the arc that we have just traced out. So the sector is basically like your slice of cake or your slice of pizza. So it's the area taken up by that arc that has been traced out. So what we want to look at in this section today is how to find the length of the arc and how to find the area of the sector, and then how to apply these questions to some a little bit more complex thinking questions. And hopefully you'll be able to get together online and work together to solve the problems that I will upload as a PDF for you. So often we can be asked in questions to find the area of the major sector versus the minor sector. So if we're looking at the arc traced out, so again, if I look at the green bit, if I put a dot on the green bit and I move a certain angle around the circle, so in other words, I trace out an arc length, then the green sector is the small sector. So in other words, it's called the minor sector. Whereas if I look at the angle, if I take theta away from 360, so that angle there would be 360 minus theta. Well, what that gives me, that yellow bit, is the major sector. So it's always important to check in the question, are you looking for the major sector or the minor sector? So how do we find the length of the arc? So we said already that the arc is a fraction of the circumference. So therefore that makes it quite easy to figure out how would we work out the arc length, because it's a fraction of the circumference. And the circumference of a circle is 2 pi r. And if we were looking for the area of the sector, well, the area of a sector, again, is a fraction of the total area of the circle. And the area of a circle is pi r squared. But the problem comes in when we're given this angle in degrees or in radians, because we end up with two completely different formulae. So let's have a look at what the formula are. So if we have our angle in degrees, then it's a fraction of the full circle. So the fraction is the angle traced out, theta, over the full circle, which would be 360 degrees, multiplied by the circumference of the circle, which is 2 pi r. But if our angle is measured in radians, then the arc length is given by theta times r. So that formula is written as L equals theta r. Or sometimes I tend to write it as r theta. It doesn't make a difference which way. So it can be written like that either, okay? If we're looking at the area, well then the area, if it's in degrees, is a fraction of the full circle, which is theta over 360 times pi r squared, being the area of a full circle. However, if it's measured in radians for the angle, then the area of the sector is given by a half r squared theta. So these are given to you in your maths tables, which is page 9. And both the degrees and the radians version are given to you there. So on the old course, we would only ever have worked with radians at higher level, but now we can work with both. Okay, at ordinary level, you would only be working with degrees, not radians. So let's have a look at some nice, easy examples first, and then we'll do a little bit more complex one. So we're asked to find the arc length and the area of the sector, and what we'd have to highlight here is the fact that theta is given to us in radians. So if we're looking for the arc length, well, we write down our formula first. So because it's in radians, if we go back, we can see that when it's in radians, the arc length is given by L is equal to r theta. So our radius, if we write down, is 10 centimetres, and theta is 0.7 radians. So all I need to do is sub into my formula then. So we have L is equal to 10 times 0.7. And therefore L is equal to 7 centimetres. And then to find the area, so again, if we go back or go to page 9 in our maths tables, if we're looking for the area of our sector, it's a half r squared theta when the formula, or when the angle, I should say, sorry, is in radians. So if we're subbing in our radius, it's 10. If we're subbing in our angle, it's 0.7. And therefore that gives us 35 centimeters squared. So again, O is important to remember your units. Okay, so let's look at one that's a little bit more challenging. So in this question here, we're told the arc AB of a sector of a circle centre 0 and radius 3 centimetres is 6 centimetres long. So we're given radius is 3 centimetres and arc length is 6 centimetres. And we're asked to find the area of sector AOB, area of triangle AOB, and area of minor segment cut off by the line AB. So what does that look like? Well, if we look at the first circle here, what we have is the arc AB and centre 0. And we're told that the radius is 3 centimetres. And we don't know what the angle is, but we do know that the arc length is 6 centimetres. So the distance from A to B there is 6. It then says if we make a triangle by joining the line A to B, well, we have a triangle then, AOB, with sides 3, 3 and 6 centimetres. But then if we look at removing the triangle from the sector, well, what we're left behind with is this shaded region here. And that shaded region is our segment. So we have to find the area of this minor segment, the small segment, cut off by the line AB. So if we look at that, it's quite easy, because what we're really going to end up doing is we're going to be finding the area of the sector, the area of the triangle, and subtracting to get the area of the shaded region left behind. So the first thing we need to do is figure out what is the angle theta. So I know that L is equal to r theta, and we're given L, it's 6, we're given r, it's 3, and therefore theta must be 6 divided by 3, which is of course 2 radians. So I've worked with my radians formula here. If you've worked with your degrees formula, you need to make sure you're staying consistent throughout. So now if I find the area of the sector, AOB, well, I have my angle in radians, which means I need to write down the area of the sector is going to be a half r squared theta. So therefore we have A is equal to a half times r squared times theta, and therefore the area is 9 centimetres squared. So now we have to be very careful, because we're going to get the area of the triangle. It's not a right angle triangle, so I can't use a half the base by the perpendicular height. So instead I'm using the area of a sector where the angle is in radians. So therefore that's going to be a half AB sine C, so what we were working on in the first class. But because C is in radians, then we must make sure the calculator is in radians. So of course, if you worked out your angle in degrees here at the start, then you'd make sure your calculator is in degrees. Okay, so therefore we have a half times A times B, and then theta is my included angle. So it'd be sine, sine 2. And then putting that into my calculator, I get 4.09 centimetres squared. Now you know you'll have done something wrong if the area of your sector is bigger than the area of, sorry, if the area of your triangle is bigger than the area of your sector. So this is our sector and this is the triangle. So then for the last part, the area of the segment would be the area of the sector minus the area of the triangle. So therefore the area of my segment is going to be 9 minus 4.09, which gives me 4.91 centimeters squared. Okay, so normally I would have you working in groups then for the handout that I've uploaded. So I would recommend that you maybe, meet online if possible as a few groups or pair up or in groups of 4 or 5 even. And then you're going to be working on the handout, which is questions 1 to 10. Now the answers are provided there, okay? But then what I will do later this evening is I will upload the solutions worked out fully. And therefore, if there's any of the questions that you can't follow, you just send me a message and then I'll do a solution video to talk you through how I got that answer. Okay?